Okay, the next piece has a title. By the way, this is the last part of chapter 2. Yeah, we've been in chapter 2 ever since the third day of school. Second day of school, I lied. You guys remember the very first day, maybe the second day, you had an opportunity to work on this assignment that said chapter 1 review? Well, when you turned that in, we were done with chapter 1. Chapter 1, if you recall, was just physical science, first like chapter or 2 of physical science. So anyway, moving on. Dimensional analysis, or sometimes called unit analysis. I actually prefer the phrase unit analysis because that's exactly what you're doing, is you're using the units to analyze a problem. But your book goes with dimensional analysis, so that's what we'll go. So you guys don't get your panties in a bunch. Anyway, have you noticed I've been emphasizing that you use units anytime you write down a measurement, and or the answer has to have the correct units. The units will tell you how to get to the answer, okay, using this process that I'm about to show you. This is a very, are there more ways to solve problems? Absolutely. But I have found over a few decades of doing this now that this is probably the most efficient, meaning quickly, and effective, meaning getting the right answer for the majority of students, okay? If you don't already know how to do this, and it's possible that some of you have been introduced to this, it's also usually relatively easily learned. Now, here's the advantage that I gave you guys. You always all got, well, as it turned out, it was a full sheet, but remember all those conversion factors that you were given? And you were asked to start learning those? Well, you guys have an advantage over every other class I've ever taught in my life because you got those 2.5 weeks ago. Normally, I would hand them out today and say, know these by Friday. You're welcome. So you've had all this time to learn them, right? Good morning. Yes, you are.
Wait, do we have to do it by Friday?
Sure.
We should have done it by now.
I agree with that. So anyway, now this first problem or two that I'm going to walk you through, I'm going to use something that you probably already know how to do, something that you know to teach you the technique, and so that we can start using things that you don't know. Okay. Somebody came up with a good number last period. I'm going to go ahead and go with that number. Let's convert 1/14. This is really close number. It's not exactly 0.28 centimeters, and convert this to kilometers. Now, does anyone right off the top of your head, and it's possible one or two of you do, know the direct conversion between centimeters and kilometers? Okay, I didn't think so, but it's actually very possible that some of you might know that. But I'm going to guess that many of you do know the relationship between centimeters and meters. I hope you do. You should know. What's the relationship between centimeters and meters? Yes, you do. Anyone, shout it out. 100 centimeters is equivalent to 1 meter. Would you guys agree? Now, what's the meter got to do with anything? Well, if you know the meters, you probably know how to get to kilometers. Does anyone know that relationship? Go.
1,000 meters equals 1 kilometer.
Right. Now, the technique that I'm going to show you using this idea of dimensional analysis is going to use these two equivalents, and we're going to make conversion factors out of them. And I'll show you what that means here in a second. And then we're going to use those conversion factors to solve the problem. So let's do the first thing. Let's convert 14.28 centimeters to meters. We're going to use this relationship. And from this relationship, I can make the whole key to this whole thing are two different conversion factors. One of them is this or this. Since these two quantities are equivalent to each other, I can set them up either this way or that way. And now that's what's called a conversion factor. It's what we're going to use to convert from one unit to another unit. We're going to multiply by one of those conversion factors. Would anyone like to take a stab as to which one would be the appropriate one? The one on the left or the one on the right? The one on the right, because if I do that, now my centimeters cancel. Would you agree? And I'm left with meters. Great. Now, since I've got the meters, I'm in meters, okay, I can use the second equivalent. I can make two conversion factors out of that. I can either write 1,000 meters is 1 kilometer, or 1 kilometer over 1,000 meters. Which of these do you think would be the appropriate one to use? The one on the left or the one on the right? Are you starting to clearly see the one on the right would be the best one to use there? So I will put 1 kilometer over 1,000 meters. My meters cancel. What unit am I left with? Kilometers. Now you just have to do the math. I ended up in the unit, my target unit. Great. Now you just have to do the math. I would like you to do the math, please, on your calculators, because I want to make sure that you're using your calculators correctly. It's not that this is brand new, you've never done it before in your life, but occasionally I'll get students that will mess this up and I want to fix it now. Would you like to throw out what you got? Okay. Would you like to throw out what you got? No. Would you like to throw out what you got?
1.428 times 10 negative 4.
Okay. Either 1.428 times 10 to the negative 4th kilometers or 0.0001428. Would anyone concur? Would anyone not concur? How many had a number that was closer to 0.1428? Yeah, and here's what happened. You know better than this. You just forgot. It rounded it to what? Okay, so in your settings, no, I don't know how to do this. I just know that this exists, okay? But in your settings, those calculators are weird, okay? You can set them, you can have a floating decimal point, which means it's going to give you all the numbers that the calculator can possibly give. Or your calculator has like 8 different floating decimal points, which to me is not floating, but whatever. You need to go in there, and someone might be able to help you in the room. Is there anybody that knows what I'm talking about? You want full-on floating decimal. All right, that's not the issue then. We'll pick up on this next week. I'm just kidding. Tomorrow.
Have a good weekend.
Yeah, have a good weekend.
So when you come to use the...
One second.
What I'm doing is using something that you do know and are familiar with to teach you a process that you may not be familiar with, okay? So it's going to get a little bit different later where you're not going to know what's going on. On your calculators, what would you do? You don't even have to do it if you don't want to, but what would you do? I'm hoping you would press in this value. Then what would you do? You can say it. Divide by 100. And then what would you do? Did you say divide by 1,000? Because I've had many students in the past take this, divide by this, and then multiply by that. You guys clear on why you have to divide, right? It's in the denominator. With numbers that are in the denominator, what do you do? Start. Very good. Divide. All right. So anyway, just for fun, what's the answer? What do you have? I know you did it. 10 to the negative fifth, right? Okay. And the unit? There we go. Okay. Everyone hunky-dory? Okay. Once again, like I said, it's something that you're familiar with to teach this concept. The next couple you may not be familiar with. Oh, let's try again. I need a number. I need a unit. No, wait, sorry about that. A quantity of measurement. What's volume? Excellent. I hear volume. Let's go with liters. Okay. And convert this to microliters. Does anyone know that direct conversion? Actually, there is a direct conversion. Does anyone know that?
Is it bigger or smaller?
You tell me. You're the one that memorized this. Go.
Is it divided by 1,000?
Good try, but no. Well, okay, don't say divided by. All I'm asking is, what's the relationship? It is. Do you know it? Good try. Go a little bit more. Actually, quite a bit. Go a little bit more. There you go. Okay. There are 1 times 10 to the 6th microliters in 1 liter. And again, this is one of the ones that you guys know. It seems like I'm saying that facetiously, but I'm not. Sarcastic. Okay, so anyway, I can make a conversion factor out of this, right? Actually, I can make how many conversion factors out of that? 2? 1 over that, or this over that, or this over that. So here we go. This one wasn't very hard. I just wanted to throw out the microliter thing at you. Okay, so what am I going to put in the numerator? Microliters, right? The thing you're trying to solve for is typically going to go in the numerator. So 1 times 10 to the 6th microliters, 1 liter there, liters cancel, off you go. I'm going to have you guys do this on your calculators because it's good practice for tomorrow with the scientific notation, getting into your calculators. Does anyone know a Parker-Britt? Okay. what are we expecting the answer to be near before you touch your calculators? Well, we have 10 to the negative fourth. We have 10 to the sixth. Negative 4 plus 6, 2. So we're looking at something around 100. So maybe say 528.4. Is that what you guys got in your calculators? So you don't even need calculators. What? Okay. Oh, you can. Yeah. So you do is you take this value and access your EE key, put negative 4.
Do I put 10?
No. Good thing we're practicing this, isn't it? Would you agree? Yeah, wait till we get some really good things going in here. Okay, bye now. Okay, we good? Okay, those were two easy ones. The one we did yesterday, and then the one we did today. Now we're going to make it a little bit more interesting. Young lady that's almost ready to fall asleep, I can't remember your name. What's it start with? J. Me. Number. 424.2. Oh, look at this. That is awesome. You knew I was going to do this, didn't you? Does anyone know the direct relationship between milligrams and pounds? If you do, you're crazy. Okay? But do we know a way to get to pounds from milligrams? Now, as it turns out, there's a number of different ways. Okay? So you get a choice. If you could, thank you for doing that. On the equation sheet, I'm just going to refer to half of the equation sheet because technically that's... Okay, on the bottom half of this side, you'll see the metric to U.S. conversions. Okay? Here's my recommendation to you. Thank you. Here's my recommendation to you. Do you notice I have those... Here, you can look. Arranged according to volume, mass, and distance, correct? At a minimum, I would, if I were you, pick at least one of each of those quantities to know. Now, the more familiar you are with the metric system and the more familiar you are with the U.S. system, the fewer of those that you're going to need to know. Now, if you're not as comfortable, or if you would just like to know more because it can make your life easier, know as many as you can. But at a minimum, you're going to need to know one out of each of those sets. Does that make any sense? Do you understand what I'm saying? Doesn't make any sense why yet, but do you understand what I'm saying? Now, and again, like I said, it will make your life easier if you know more of those. So, with that being said, this next thing I'm going to do is kind of a problem-solving technique that you can use when you are given something like this that you don't know how to get there for sure. Would anyone like to offer a suggestion on how to get from milligrams to pounds? Give me one suggestion. Milligrams to grams, and then from grams to pounds. You can do it that way if you know that relationship between grams and pounds. Okay? What's another way you can do it? Go. Oh, is that on there? Oh, geez. I don't even know if I know that one. Give me a second on that. It's like 28.3 or something like that? Yeah. And then, okay, so if you're comfortable with the ounce to pound thing and the gram to ounce thing, there's another way. How about milligrams to grams, grams to kilograms, and kilograms to pounds? Would that be a potential? Right. So again, are you starting to recognize what I meant by the more of those you know, your life may become easier? Because here we have a 2-step process. Here we have a 2 4-step processes, or 3-step processes. Does that make any sense what I'm saying? Clearly you would like to do less work, but hey, sometimes you have to do more work. You still get there. We'll do 2 of these just for fun to show you're going to get the same result. Okay? So, let's go ahead and start. Somebody, well, you're always going to start with what you know. So let's go with a 424.28 milligrams. We'll go ahead with this first one that someone mentioned. What is the relationship between milligrams and grams? Go.
If there was 1,000 milligrams in a gram.
That is correct. Now, with that being said, what am I going to put in the numerator? Go. Yeah, the thing you're trying to solve for is typically going to go in the numerator. So what she said. And, well, I'll go ahead and do the canceling so that you guys can see that. Okay. And next, let's pick somebody that never answers. So, orange shirt.
What do I do?
Well, you're telling me how to go from grams to pounds. Now, I clearly know that you don't know that, but you do have the information available to you. You never read your cereal box, do you? Yeah, this is on all your cereal boxes. Yeah, absolutely. No. What do you got? Very good. Now, with that being said, everyone heard her, right? She said 453.6 grams. Which goes in the numerator? Anyone shout this out? 1 pound. Very good. Grams cancel. We're left with pounds. Please do the math correctly.
You just got me first.
You have it? Do you feel confident? No. Okay, go ahead and throw it out there just for fun.
Okay, I got 9.35 times 10 to the negative 1 pound. Or you don't remember?
Well, you tell me. How many significant digits are in this?
5.
Okay, so if there's 5 in this, should I lose any on the way? The answer would be no. Okay, because all we're doing is converting. Okay? Now, why don't I consider these? They're exact numbers. See where I'm going with that? We're going to assume our conversion factors are exact numbers. Okay? So, do you have more? Should have 2 more, right?
Yeah, 9.3536.
3536. All right, would anyone concur with that? Does it make sense? Should be significantly smaller, right? And that is.
So, you do 1 to 24, 1 to divided by 1,000, divided by...
Boom, there you go. Can't do it any faster. What's that? Yes, you get 9 times 10 to the negative 4th. Okay. How are we doing on this? We good? I'm going to walk through 1 or 2 more with you and then give you guys a couple to try on your own. Oh, wait. Let's pick another one just for fun. I don't care which one. You with the yellow pencil. Which one do you want to do? Top or bottom? Yeah. Top. Ooh, this is yours, isn't it? All right, here we go. So 424.28 milligrams. We're going to start the same, 1,000 milligrams per gram. What did I say, 28.3 ounces per gram? And everyone knows how many ounces are in a pound, right? 16. Whoa, that was weird. Is it what? 3.5? Ooh. Okay. Okay, try that one. See what you get.
They're all the same. The 1 pound and 28.
I'm gonna do it. Well,
Should be.
you did it with the pound.
Huh?
I was going to say 28.35 ounces in a pound were the same, but because when I read 28.35, I was thinking it's the grain.
Yeah,
Cool.
you divide it by 1,000.
Hold on. What's wrong with this picture?
You meant to say.
No. What's wrong with this? Okay, I'll fix it for you since everybody's not really sure what's going on.
Oh, wait.
You got to catch these things. Wake up earlier. Drink more coffee. Ha!
Like Harley here
Just out of curiosity, we might come up with a slightly different result towards the very end here. Go?
My calculator does like .00.
Yeah, excellent. Just convert.
Wait, I
Oh, okay. So you need to set, and somebody may be able to help her with this. I know what needs to be done on that particular calculator. I don't know how to do it. That it needs to be set to floating decimal point. However, with those billion-dollar calculators, there's like 8 different floating decimal points, which I don't understand. Okay? So that needs to be set to pure floating decimal point. Does anybody know what I'm talking about? 1. And 2, how to do that.
No, but I got it right now.
Yeah. So you need to talk to someone that knows on how. You know how to do it?
He knows how to do it. Really?
Wait, on this one?
Okay. Anyway, just out of curiosity, could someone provide their answer for me? Did you get it?
Yeah.
What? Oh, really? Even out to here?
Mine.
Oh, okay. Wow. There you go. So, the point I was trying to make there, different numbers of you are going to have different knowledge levels and different paths that you want to use to get to the answer, but the point is you're going to get the same answer. Okay. All right. Let's mix it up a little bit and have a little fun. Could I have a number, please? I already picked on you today. Can I have a number, please? You have an infinite number of answers.
456.98.
Excellent. 400. And didn't we do 4.5698? I got the rest of it. Ha. So, what appears to be the issue this time? Go. Units! 2 different units that need to be converted simultaneously. You can do this. Now, some of you are immediately thinking, well, maybe I can just convert the grams to pounds first, and then do the liters to ounces separately. As it turns out, with this technique I'm showing you, you can do both of them all in one shot, which is the beauty of this. Okay? So, just because we never got to do it last time, well, first of all, you can pick one of the units. It doesn't matter which one you decide to solve for first. It just flat out doesn't matter. So, pick a unit, gram or liter. He wants to pick liters. Okay, so how are we going to get from liters to ounces? Now, we already did ounces, but that ounce was a weight measurement. This is referring to a volume measurement. It's not a liquid. Okay? So, does anyone know the direct relationship between liters and ounces? I don't either. So, where can we go? No, absolutely not. Yeah, go ahead and go to Google. Seriously, just use the heck out of Google, okay? Because when you have your quiz and your test, guess what you won't have available to you? Absolutely. So then you are screwed. No. No. This is why I said exactly 3 weeks ago, you need to know these. Does anyone recall me saying that?
Wait,
Well, that's unfortunate for you.
is there like a trick to remember liters and ounces or not?
Yes, time.
Are you serious?
What's her name?
Alexis.
How do you know that?
Because I've known them for a while.
Right, you get to need to know these for a while. Here we go. Does anyone know the direct relationship between liters and ounces? I do not, but we can go from liters to... Can't go from meter... Okay. If you want to go that route, I would probably go from liters to quarts, and then quarts to ounces.
There's full sports and...
Okay, so we're going to go from liters to quarts, and then from quarts to ounces. Now, does anyone know the relationship between liters and quarts? Well, it's sitting right there on your paper, but you're going to... I'm going to tell you right now, that's a good one to know. That is a good one to know. Okay? There are 1.06 quarts for every 1 liter. Now, notice what I did differently this time. I made sure that I arranged my conversion factor so that the unit that I'm trying to get out of cancels. Did you see what I did there? My liters cancel. I'm left with quarts. Now, does anyone know the relationship between quarts and ounces? See, I told you guys that you know the metric system better than you know the U.S. system.
32.
It is 32. Now, you looked that up, right? I think you looked that up, but... Anyway, so, we're now in ounces. Would you guys agree? But now we have to get our grams to pounds. I'm going to go a different way this time than we did last time, because again, different people are going to remember different things. I'm going to go to 1,000 grams for every 1 kilogram. My grams cancel. And then from kilograms, I'm going to go to pounds. There are 2.205 pounds for every 1 kilogram. You can string these things along forever if you want to. Yes. Okay. How so? Watch this. Grams are here in the numerator, yes? Grams are in the denominator, so they cancel. Right? Kilograms are in the numerator. Kilograms are in the denominator to cancel. Are you okay? But thanks for paying attention. Seriously, you got to pay attention. Good job. And now just do the math. The efficient way to do this on your calculator would be take this, divide by this, divide by that, divide by that, multiply by that. You can't screw it up. Got it? Oh, sure.
Only going to two, right?
Pardon?
We're only going to two, right?
To what?
Two significant.
No, we're going to 5 significant digits because, as I stated earlier, the conversion factors we're assuming are exact numbers. Do you have something? What do you have? 2.9706 times 10 to the -4th. Now, what's the unit? Pounds per ounce. Now, some of you might be more comfortable with calling that a fluid ounce, just to differentiate it between an ounce of like a weight measurement. Your choice. Okay. Did anyone concur? You guys good?
I don't know what I did, but...
Okay.
I forgot it.
Listen, that was a pretty extensive one. Would you agree? However, do you see the function, the usefulness of this idea? You can string these things along forever if you want. We almost did. Okay? So, they're not all going to be quite like that, but clearly you can. And as the year goes on, you will. There's some things that we're going to do that are going to be remarkably similar to this setup later in the year. Okay. Any questions before I give you a couple to try? Ms. Thompson?
Yes.
It just got hard. Can you tell the difference? Yeah, it just got hard. All right, so here we go. Let's try these 3 or 4 on for size.
That'd be like 7,000.
Now, my suggestion to you would be to do as much of this as you possibly can without looking at the sheet, because you're going to have to wean yourself off of that. Okay? Now, currently, since many of you haven't spent the time needed to get familiar with that stuff, you probably won't get very far and you're going to have to go to the sheet. But I think you're starting to clearly see what I meant by you have to know these.
Yeah.
Okay? So start trying to wean yourself off the sheet. Yes? Oh, gosh, no. No. No, you haven't even... You're going to have like 5 rounds of practice on this. I mean, we're talking a week's worth of practice.
This is tomorrow. I was like,
No, tomorrow. We already covered tomorrow.
I thought it
I was
was
gonna say, so like, what, that most rearranging?
No, God, I spent 3 minutes at the beginning of class talking about what is on tomorrow.
So I'm fine for like another week.
Yeah.
Okay. Let me see. Okay, I know what I do. So we got mass, we have volume. What am I missing? What's that? Thank you. Let's do a distance. And then lastly, there we go. Go ahead and try these 4 on your own.